but it wasn't super good. This was for
I have gotten an email to question number 1 from our first assignment. So in Wiley Plus, you have homework due Sunday night, and you have homework due in Canvas. So we'll make sure we look at both. And each Sunday night, you should double check both Wiley Plus and Canvas to make sure you haven't missed anything. So just chapter 1 is due this Sunday in Wiley Plus. But the question I had gotten emailed was this problem. One day, Sierpinski began a creation with, as always, a perfect purple square. However, one square seemed too plain. So in the exact center of it, he added a gold square. He saw that the central square implicitly defined 8 purple squares surrounding it. As he pondered, he realized that those 8 purple squares were identical to the original large square, except for 2 things. So he starts with this purple square on the left, puts a orange square in the middle, or a gold square, and that gold square defines these 8 squares around it. So each of these little 8 squares is like this original square, except they're smaller. So they're 1/3 as wide. If you took a tape measure and laid it along these squares, they'd be 1/3 as wide as the whole square. And also, none of these little squares has a little gold square in the middle like he added to the original one. So those are the 2 things that you need to check off in that box. Does anybody have other questions on assignment 1, chapter 1? Okay, well, we'll be looking at 2.1 to hand in for the following week. So if you have questions on 2.1, then we can go over those Monday or Tuesday or Wednesday or Friday. Yes?
So for when it says like the mindscape for that chapter, do we have to use all of those?
Yes.
Okay.
So you have, let's see, 1, 2, 3, 4, 5, 6 mindscapes here to do. You just click down the side and do them. Okay. Any other questions? Okay. Yes.
So far for the in-class activity, it's our name placard with the dodgeball thing and the item we were bringing on Wednesday, right?
I'm not sure. That's what I was just going to check. So I'm glad you asked that. So you can see due dates on your work. And that's how you can know what you have to get done. And Sunday night you can check those due dates. I don't move due dates near, but sometimes I move them farther off if we didn't quite get as far as I thought we would. So if you look at your assignments, then you'll see this so dodgeball, which we did in class, and then the million items, which we did in the last class, and 2.2 pine cone or pineapple, which we'll be doing in a little while later on today, okay? So those are the 3 that are due this Sunday night on Canvas. Any other questions?
Looks like the pine cone one is February 9th.
Oh, I wonder why I moved that. Okay, well, that's where it is then. So you have a while. We'll be doing it today, though. Any other questions? So I answered my questions that I had gotten asked. The author starts each section off with a question, and then there's also a life lesson to go with that section. So we've been looking at the pigeonhole principle. His life lesson to go with that is that often we learn a principle of logical reasoning. We may see, after we learn a principle of logical reasoning, we may see many instances where it applies. So I hope after we talk more about the pigeonhole principle today, you'll be keeping your eyes open for more applications of the pigeonhole principle. Let's write it down again. This time we'll write it down the way I put it on the quiz. I always want you to get the very best you can on the quiz, so I'm always trying to help you know what to expect on the quiz. So we'll look at the pigeonhole principle again. The pigeonhole principle said if you have n boxes, So this one's stated a little bit differently. We're going to have n boxes. So n just stands for a number. The number might be 100, it might be 1,000, it might be 1,000,000. If you have n boxes and n plus 1 items to put into the boxes, if you have n boxes and n plus 1 items to put into the boxes, so one more item than you have boxes, one box will contain at least 2 items. And that doesn't mean that more than one box couldn't contain at least 2 items, but at least one box will contain at least 2 items. So the pigeonhole principle, if you have n boxes and n plus 1 items to put into the boxes, one box will contain at least 2 items. So you have one more item than you have boxes. This is the way it's phrased on the quiz. So oftentimes on a quiz I'll give you a principle with a few words removed, and you have to pick from a list of words and put the correct words in. So you need to know the pigeonhole principle enough to be able to do that. And you also need to be able to use the pigeonhole principle. So we're going to look at some examples of questions that would be good quiz questions, and we'll hopefully get you thinking about how the pigeonhole principle can be used. So we used it to figure out if at least 2 people in the world have the same number of hairs on their bodies. Now we'll look at some other examples. So the Super Bowl is coming up. Who's going to watch the Super Bowl? Yeah, quite a few people. Not as many as if the Packers were playing, right? Who'd watch if the Packers were playing? Yeah, even I would watch. All right. So the Super Bowl is coming up. So at the Super Bowl, will 2 people in the stadium have the same birthday? Okay, so I mean the same month and day, not necessarily the same year, but the same month and day. Will 2 people in the stadium have the same birthday? Yes, no, or cannot be determined? Yes, yes. And how come? Because there's going to be more than 365 people there. And I'll say 366 for leap year. So there's going to be more than 366 people there. So our fallback way of trying to figure things out is to make little rooms that we assign people to. So if we take at the stadium and say this seat is for the person born January 1, for the person born January 2, the person born January 3 and 4, and go on all the way, and number seats all the way to December 31st. There's going to be people sharing seats. There's just no way to fit all the people in the stadium on 366 seats. If we include leap year even, that's not enough. Okay. How about a little harder one? Okay, this time we have tennis ball cans. We have 5 closed tennis ball cans of standard size. Does anybody know how many tennis balls fit in a tennis ball can of standard size? 3, that's right. Okay. Okay. So tennis ball cans each hold up to 3 balls. So the question is, can we know for certain, without looking in the cans, Okay, we know for certain without looking in the cans that 2 cans contain the same number of balls. That 2 cans contain the same number of balls. So again, yes, no, or impossible to tell without looking. Anybody want to say? Yes.
Yeah. Maybe.
Good. Good. Yes, that's correct. Because you can make a room. We'll make little rooms here for all the cans that are empty with no balls. Make a room for all the cans that have 1 ball. A room for all the cans that have 2 balls, and a room for all the cans that have 3 balls. And if you take these 5 closed cans and put them each in the room, depending on how many balls they have, at least one of those rooms has to have at least 2 cans. So it might be that all the cans are empty. And then all the cans would go in the first room. But there's no way 5 cans can each have their own room when there's only 4 rooms available. Only 4 options available. Anybody have any questions on that? Let's try one with dice. How many dice, okay, and these are 6-sided, how many 6-sided dice would you have to throw to be assured of a double? So doubles when you get 2 dice that show the same number. So you have as many dice as you need. How many dice do you have to throw to make sure you get a double? What is it? Maybe? Okay. 7. Yeah, 7. Good. Because when you throw a dice, you'll get a 1, a 2, a 3, a 4, a 5, a 6, or a 7. Oops, no, you won't get a 7. That's the whole reason you need 7. Because you might get a pair of dice on the first 2 you throw. But you might not. You might get a 1, and then a 2, and then a 3, then a 4, then a 5, and a 6. But when you throw the 7th dice, then it has to be a repeat, even if all the other throws were different. So as we look at using the pigeonhole principle, we kind of take this idea of, well, how hard could it be? I mean, could it be that you don't get a pair right away? Yes, it could be. It could be you get a 1 and then a 2. Could it be on the 3rd throw you still don't get a pair? Yes. And we just keep going on, like, how long can we go before we've used up all the possible options and we have to get a pair? Let's try some with cards. Now, when I was your age, almost everybody played cards. We did not have Nintendo, okay? So we all knew how a deck of cards work. But some of you don't play cards. So let's talk about a deck of cards. Okay, so there's 4 suits in a deck of cards. Hearts, diamonds, clubs, and that's not a spade. Hearts, diamonds, clubs, and spades. Okay, 4 suits. And then, who plays cards? How many cards do you have in each suit?
52.
52 total. Good. And how many in each of the 4 suits? 13. Good. 13 in each. 13 cards in each suit. So you have the ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So we'll be using other problems with decks of cards throughout the semester. And like you said, that adds up to 52 cards. So this one's going to be a little tricky. How many cards must you draw to be sure, we'll say to ensure, to be positive, to ensure 5 cards of one suit, 5 cards of one suit. What do we call 5 cards of one suit? Anybody play cards enough to know that? Anybody? It's not a pair, it's not a full house. Flush. Flush. That's what you're going to say, right? Okay, so think this out. Think about if you keep drawing cards and you don't get 5 cards of one suit. How long can that go on for? How long is it possible to keep drawing cards and not get 5 cards of one suit? And then when does it happen that you have to have 5 cards of one suit? Okay, so we work that out, see what we can get. Anybody know? This is a harder one. Okay, so suppose you're throwing hearts or drawing diamonds or drawing spades or clubs. And we keep not getting 5 cards of one suit. So maybe you get a heart, and then maybe you get a spade, then another heart, then a club, then a diamond. Okay, how long can you go on doing this before you have to get 5 cards of one suit? Yeah, 17. That's right, because you could get 4 in each. And then, finally, when you have 4 of each, you have to get a 5th card that's matching one of the other 4. So that makes 17. So that's a pretty tricky one. Now you could get 5 cards in one suit on your first 5 cards that you deal. Okay, but we're looking at how many to make sure that there's no other possible way but that you have to have 5 cards in one suit. Sometimes the screen freezes up. Anybody have questions so far? Okay. Well, how about a pair? How many cards must you draw to ensure a pair? A pair means like 2 jacks or 2 sevens. 2 threes, 2 of the same number or face card. So think of yourself dealing out these cards and you just keep not getting a pair. How long before you have to get a pair? Yes?
14.
14, good job. Okay, so maybe your first card's an ace, then you get a 1, whoops, that's an ace. Then you get a 2, then a 3, and so on. And you get one of every one of these 13 cards, put dot, dot, dot there. One of every one of the 13 cards, then your next card has to give you a pair. On your Wiley Plus, you're going to have several questions about either socks or gloves. So I have one here about gloves. So you have 3 pair of gloves in a box. How many do you have to pull out? To be sure, okay, to be positive, to be sure of getting a left and a right. So there's 3 pairs of gloves. So there's 6 individual gloves in a drawer, and they're all mixed up. They're not matched together. How many do you have to pull out to be sure of getting a left and a right? And again, you think it out, okay? So make your rooms, and think about how you could be pulling these gloves out without looking at them. So you could get a pair in just 2, but you might not, right? You might have 2 lefts. You could get a left and a left. If I keep getting lefts, how long could I keep getting lefts? How many times could I reach in and get a left instead of a pair? Yeah, 3. And then what happens on the 4th one? You get a pair. Yeah. So you might get a pair right away. You might get a pair with 2. But to be sure of getting a pair, and you're running out the door, grab 4. So you'll either have a pair or 2 pair, or 3 lefts and a right, or 3 rights and a left. But for sure, you'll get 1 pair out of 4. So all of these were good quiz questions, and if you're planning ahead and studying for your quiz, you might, write quiz there on those questions and on the questions above there. Okay, they're all good practice for your quiz. Hopefully, as you go about the day, you'll see other situations where the pigeonhole principle can apply. We're going to move on to take a look at section 2.2. Section 2.2 is called the Fibonacci sequence. How many of you have heard of the Fibonacci sequence? Oh, that's good. A few of you have. Good. Okay, so we could write down that, I guess. Let's write 2.2 Fibonacci sequence. Thank you. 2.2, the Fibonacci sequence. So that's named after Fibonacci. He was working in mathematics around the year 1200. So the question here is, what's the next term in the sequence? We have pine cone, pineapple, daisy. What comes next? So let's take a look at the pine cone and pineapple. And if you can picture a daisy, what in the world do these have in common? Why would they all be together in a sentence at all? Anybody see some similarities between these?
With little things going on.
Okay, so they have these little things sticking out.
Yeah.
That is why we gather them together. So they have these I don't know what they're even called, nodules. Well, it turns out that you can count these. Remember, we want to quantify, so we're going to count them. And we're not going to count each nodule. What we're going to count is the spirals that they make. This particular pine cone has spirals that are blacked out every other row. So the ones that are blacked out, it's a little easier to count. So you have these spirals going down, and I would count off how many spirals there are. And it turns out you have spirals going clockwise and counterclockwise. So not only am I going to ask you to count the spirals going clockwise, as these are sketched, I'm going to ask you to count the spirals going counterclockwise. Now it turns out that pineapples, unless they're malformed pineapples, should all have the same number of spirals going one way and going the other way. And pine cones also have a different number of spirals, but among pine cones will have, well, there's most of the pine cones we have here should have the same number of spirals going one way and then the other way. So I'm going to ask you to count them, okay? Count the spirals going clockwise, count the spirals going counterclockwise. With your pineapple, you can put your fingers on one row, and then that's your starting row, and then count. So 1, 2, 2, 3. So there's 1, 2, 3, 4. At some point, you have to get kind of dexterous and turn it and continue your counting up to wherever you started holding your thumb down. And then go the other direction. Okay, so holding the pineapple, you go 1, 2, 3, and then keep going. Turn the pineapple and keep going. So that's what I'm going to ask you to do. Online students, you can be counting yours also, okay? And I'll come around if you're stuck and maybe give you a hand. I have a few extra. Does anybody need one? Did anybody not bring one? Okay, so I don't know if I have enough for everyone. Yours are easier because I put. Okay, yeah. Yours might be easier because some of these are more. Well, I know I could grab this one.
Yeah, I don't even know. So this one's clearly defined 1. Then the next one's open.
Maybe we'll have to share.
3.
I don't know. Okay.
4.
Can you share?
5.
Okay, got it.
6.
Too hard. Or too long.
Or I could bring you a pineapple.
9. 10.
This is also your class activity.
14.
This is also your class activity, so at some point take your pineapple or pine cone and you can take a great selfie with yourself in it if you want to. Otherwise you can put your name in it, okay? But I think it's fun when I see your faces with these.
Wait, so I see a picture with my.
Yeah. Or with
Do this.
how do you count the other one?
So it's like.
Okay, so I went this, I said I went this one.
Yeah.
Okay. So 1, 2.
So you can compare with the people around you, okay?
I must start here. 1, 2,
Oh my god.
4,
Oh no.
5,
Oh my god. My roommate just told me she's gonna have
6, 8,
Whale, that's
9, 10, 11, 12.
Let me see how you're starting. You have a very superior pineapple. This is okay. Oh, now you're going the other way.
Yeah, I think I'm going the other side.
Okay.
13 would be like down here. 14.
I'm trying to with my pineapple.
16.
No, sometimes these are just too fun, but I can see this is one.
Okay.
Did you do that?
And if you want, you can take a marker and mark one, and the other one
I don't know.
off.
So it's every other one, that's what it is?
No, you're counting all of them, but it's easier to tell them apart if you
Just
mark
gotta
every
taste
other
it.
one. If you mark everyone, then you're like, well, I don't know where I went.
Alright,
Yeah,
I'm gonna take a picture with my pineapple.
Oh, probably.
Well, pardon?
Absolutely not.
Did you just say I? Did you call me?
Yeah, call on you.
So I'm gonna start crying now.
Look at that. How beautiful. Honey, my face. I was just a bit. Oh my god.
That's what I did.
But like yesterday.
Mark this row,
Then
and
you
then
should
this
take
row, and then the next row, so then-
So, no, I don't have the software on all of them.
So we're counting the spirals. So the top is the first layer, and this spiral. So this is one spiral. And if you mark off the first one, and then just second step, and then you do the third step.
How's it going?
It is really tight, but it's hard to count.
Yeah.
Did your hair color?
Yeah.
So what we're doing is no, it keeps going. So this is one spiral.
You're back on with the market.
So hard for the pressure. I gotta be in it, but
Now don't do the one right next to it, because then
No, like,
all of a sudden they're all
what's
marked and then you
happening?
can't
She
tell.
decided to move out.
Like go every other one and
Text
then
me, go, hey, you want to move out? Then I have to go.
Yeah, so you know what I mean?
And you? Why?
Well, we don't even talk. Like, we get along so we don't talk unless it's an emergency.
Who's your roommate? Are you not friends?
We are. Oh, I'm not moving in with her.
The twirl.
She's going down
The roads.
It's like,
Okay,
oh, thanks.
I'm gonna gather the marked ones up and we'll go over some of the marked ones together, okay? So who has some of mine together?
That makes sense. Like, she didn't, after break, she didn't put any of her trust out. I don't know.
Are you in a restaurant?
Huh?
Are you in a restaurant?
Yeah.
What building? Oh,
Very close.
so you guys know each other.
Yeah.
She's like, what are you bringing for your million?
So you know Seth. He's my best friend. I'm an RA over 16. So I watch you guys.
I know that because he knows my name. Everybody, like, hi, everybody. I walk, I'm like, oh, hi. Yeah, but I don't know if she's moving to a different hall or she's staying in the same hall. Yeah. You know?
Let's look at these together.
Well, it's better than going for free for
So we're counting the spirals. I think this one's marked pretty well. Does it show up on there? Kind of. So I've marked this with silver nail polish and brown nail polish. So here's 1, 2, 3, 4, 5, 6, 7, 8. So you should have had 8 going counterclockwise on your pine cone. 8. It's kind of hard to see. That's what it should be. And then going clockwise, I've got this one marked too, but some of the silver flaked off. So we have 1 row of silver, 1 row of brown, 2nd row of silver, 2nd row of brown, 3rd row of silver, and then we're back to the first. So 5 on that one. So you have 5 going clockwise and 8 going counterclockwise on your pine cones. Some pine cones have 8 and 13, but most that you find in our area would be 5 and 8. And then the pineapple is harder to count. You should have found 8 and 13 unless your pineapple is malformed. Okay, so sometimes all of a sudden the little triangle shapes kind of merge together and they're all goofed up. But there should be 8 and 13. Okay. This one has 8 and 13. I double checked before I bought it. Like, you gotta work. One of them has to work. Okay. All right. Now we're going to look at daisies. That was next in your list from your author. So we have daisies. Okay, can you please count those? Okay, we have spirals going clockwise. And we have spirals going counterclockwise. Okay, so that's hard to count, right? I'm going to give you a little piece of paper. Online students, you can print these off from the class activities. On both sides of the paper, you'll see the same daisy marked with spirals going one direction and the other. So these will be easier to count than your pine cones or your pineapple.
Yes.
Okay, so I'll hand these out and you can count them. And you can write on these and then dispose of them so you can not have to worry about marking them up so that you have better.
Well, I won't have to put my contacts in the dark anymore.
A few extra. Okay.
Oh, it's
That
on
one's
that.
right there. Yes. Oh yeah, this one's on the back. Okay, so there's one on the front and one on the back because it's clockwise and counterclockwise. Once you have it, confer with the person next to you and see if you have the same numbers, okay?
I got 34 by 21. Oh,
I just started like coloring that as you see the different colors.
Did you get 21 going one way? 34 the other? Good job. Good job. Okay, next comes sunflower. No, I'm just not kidding. We're not going to do that. Okay. But I'll tell you what it is. So we have all these numbers of these spirals on this foliage. Let's go ahead and write them in order. Five, 8, 13, 21, 34, 55, 89. What number would come next?
Whatever 89 plus 55.
Good job. That was right. Whatever 89 plus 55 is. $144. So very good. You spotted how these come about. We have 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. 34 plus 55 is 89. 89 plus 144 would be the next number. Go ahead and find the next two numbers, please. Yeah, probably need a calculator. So 89 and 144 is 233. 144 plus 233 is 377. How long could we keep doing this?
Oh.
That's right. That just goes on and on, doesn't it? What about the other direction? What would come before the 5? 3. Good, because 3 plus 5 is 8. And before the 3? 2. Good. 2 plus 3 is 5. Before the 2? 1. 1 plus 2 is 3. And before the 1? 1, because 1 plus 1 is 2. Now, if you want to, you can go backwards from that. You can go to 0 and negative 1 and so on. However, we're going to stop there, okay? So most of the time when we look at the Fibonacci numbers, here's where we start. And we got this from vegetation. Fibonacci got these numbers from rabbits. So you have one pair of rabbits, and then they grow old and have, then they're ready to have babies, and then they're old enough to have babies, so the next month they have babies. And then you have 3 pair of bunnies, and some of them are old enough to have babies, and they do. And so you can follow that through on one of your homework assignments. So that's how Fibonacci came up with these numbers, and we find they appear in a number of places. So we'll be looking at these numbers geometrically later on. For today we're going to look at them as numbers. So mathematicians think this is fun to explore numbers. Hopefully you'll find it mildly interesting. We're going to consider the ratios. So a ratio, you take one number and divide it by another. So the 1 divided by 1 is 1. And then the 2 divided by 1, that's 2. The 3 divided by 2, that's 1.5. And then I'm going to ask you to do some more using your calculator. 8 divided by 5, 13 divided by 8, 21 divided by 13, 34 divided by 21, 55 divided by 34, 89 divided by 55. So write these out to 4 decimal places. Remember how you round in the 4th decimal place. So you have, if the next number is 5 or more, then round up. So go to 4 decimal places, and then if the 5th decimal place is 5 or more, you round the 4th decimal place up. So use your calculator, please, to do that. So when I first wrote these down for you, I missed the 5 divided by 3. So if you caught that and wrote that in there, that's great. 5 divided by 3 is 1 2/3. So 1.6667 when you round to 4 decimal places. 8 divided by 5 is 1.6. 13 divided by 8 is 1.625. 21 divided by 13 is 1.6154. 34 divided by 21, 1.6190. 55 divided by 34, 1.6176. 89 divided by 55, 1.6182. And we could keep doing this forever as well, right? But we can see what this is approaching. As we look at ratios, they approach what value? Well, let's see. They're getting, after 5/3, we start getting a 6 in the first decimal place. And then after 21/13, we get a 1 in the 100th decimal place. And then that stays. If we wanted to see what the third decimal place is, we could keep doing more of these. And then we'd get a number that stays constant in the third decimal place. And we could do that for as many decimal places as we want to see future decimal places. Because this ratio approaches a number that has a name. The name is phi. It's a Greek letter, phi. Pronounced phi like a fee you pay on an ATM, but it's the number phi. Phi is the ratio, the number that we get as the ratios of the Fibonacci sequence go on forever. We're going to explore that number more and see how many different places it shows up. It shows up in the strangely surprising, diverse number of areas. So we'll look at that further on Monday. So come back on Monday and we'll look at this some more. Don't forget to upload your picture of your pine cone or pineapple. Have a good weekend.
I get on my shoe for 3 years every day. Still here. Like, no lie. One of the years, like, second grade, so every morning I would count my shoes. Like, as I did. Things that would, like,